All right. Hello and welcome to Kuka Tools Accelerator Training. For next gen automation, iiQKA OS2, iiQKA IQWorks, and KRC5-2. So during this session, we will cover iiQKA.OS2's single operating system, go over virtual startup, user-friendly interface, and advanced engineering, and iiQWorks and KR-2. My name is Jules, and I'll be your host for this session. Thank you for joining us today to hear Pat Duda, Key Technology Manager from Kuka Robotics. If you have any questions for the presenter, please type them in using the Q&A box found at the top right side of your screen, and we will address as many of them after the presentation. Now let's hear from Pat.
Well, thank you, Jules. And thanks everybody for joining today to hear about our new software and hardware platform. Kuka has completely updated the robot controller and operating system over the past few years. I believe this is a revolutionary step forward in our technology platform. Today, as part of our North American rollout program to launch iiQKA OS2, iiQWorks, and the KRC5-2 controller. The core mission of our new controller and software is to make it easy to use, making automation faster to realize, with the goal to shrink the time it takes to completely design, deploy, and start up production. If you've been in robotics just a few years, you probably had an experience that was not easy. When we were planning this, my colleague and I talked about it, and he shared a story that illustrates the point. For the sake of the story, let's call him Rick. Maybe you can relate to it. You know, the feeling when a project took longer than expected, where problems popped up on the factory floor, and it had to be solved under extreme pressure of a looming production date. The story goes like this. One frigid January in Wisconsin, we were called to help an integrator program, test, and prepare an automation cell to do a runoff for their end customer. It was a line that included multiple palletizing and depalletizing cells that were handling layers of cat food cans. Each cell was relatively complex with many robots. The cells needed to both run in palletizing and depalletizing mode at the flip of a switch. The team worked really hard to meet the runoff target for an upcoming Monday, and the end customer was making a special trip to fly in for the event. Each cell had a controls team to wire, program, and test the cells. One group was working on the palletizing part with one of the cells, and the second group was working on the depalletizing in another cell. And all the implementation was done directly on the floor with the real equipment. The two teams were working side by side, but they really weren't talking with each other. Nothing could go wrong with that, right? After the weekend and lots of late nights leading up to it, the Monday morning deadline arrived. We were in the system and it started out okay. We were able to depalletize almost a complete pallet in one cell and completely palletize in the adjacent cell. We started to feel relief as things ran well. Then the customer did the test to flip that switch and reverse the flow of the material per the requirements. Everything fell apart at that point. The conveyors stopped working, the pallets were stuck, and robots went through full stacks of cans. There were cans everywhere. It was a complete mess. We all stood there in stunned silence. And we have a video. So it felt something like this.
Who's responsible for this?
If something goes wrong, you find a scapegoat.
Rick.
It's what you do.
What'd you say?
So those pain points can really hit us, but Kuka is really focusing on trying to make it easy. This is our new mission. We understand that customers don't just want robots. They want solutions that start up, program, and integrate easily. They want a system that they can work with seamlessly. That's why we're focused on always improving and simplifying every step of the automation journey, from planning and setup to maintenance and upgrades. Every interaction with Kuka will be focused on making it easy. With our new products, we are empowering users at all skill levels to harness the full potential of robotics. For decades, Kuka has been synonymous with innovation in robotics. We built robot arms that make the cars you drive, the electronics you use, and even medical procedures that save lives. But the world is changing, and changing fast. So before we introduce the new product, I want to talk about how Kuka is focusing on upcoming megatrends. We're not just responding to these trends, but actively shaping them and building tools that empower you to thrive in the coming era. Let's explore 3 of these transformative trends as highlighted in the report released in 2024 called A Roadmap for Robotics, Robotics for a Better Tomorrow. There's digitalization, robotics as the embodiment of AI, and changing demographics in the workforce. So let's take a closer look at these. With digitalization, we've been witnessing an accelerating shift to a digital economy, transforming everything we do, from how we shop, social interactions, as well as manufacturing. We have high expectations that what I see today can be in my hands tomorrow, sometimes even only in hours. In manufacturing specifically, this means a massive push towards digital transformation, demanding seamless integration from design to simulation to delivery. It includes creating entire factories in virtual spaces. For decades, industrial automation is focused on speed, but with digitalization, it's really about data and adaptability. Digitalization continues to drive Industry 4.0 and the next wave of industrial innovation. Systems of the future need to be digital ready from the ground up. Everybody's talking about AI, and robotics as the embodiment of AI gives the ability for automation systems to work more autonomously. Robotics and AI are tightly coupled together with exponential growth in these areas. Robots are moving beyond repetitive tasks. Now it's about intelligent, adaptive robots capable of perception, planning, and learning. Moving from deterministic algorithms, where you just follow a canned sequence, now systems are able to operate in an intent-based AI with decision-making and real-time updates to the environment. This megatrend is pushing us to develop systems that are not only powerful, but also intuitive, capable of understanding and adapting to the dynamic complexities of the real world. This will fundamentally change the field of industrial automation, enabling new levels of physical interaction and problem solving. And one more point about that is that the CEO of NVIDIA, Jensen Huang, was quoted as saying that robotics ChatGPT moment is just around the corner. And we're preparing for that moment to make it a reality. The changing demographics is perhaps the most impacting trend in our world today in North America. We face a workforce shortage in North America and globally, and we see only 7 workers available for every 10 open industry jobs. The overall shift with an aging population and decrease in the number of children per family means a shrinking workforce. Today, manufacturers struggle to find enough skilled workers and to find people skilled in automation itself. This megatrend creates an imperative. We need to leverage automation and robotics to increase productivity and make complex technologies easier to use, adapting to new ways to work. This challenge will bridge the skills gap and provide technologies that allow new users to enter the market, reducing the complexity of the automation process. So this all leads to the requirement of making systems that are intuitive and easy to use. Bringing this all together, considering those pain points and making the automation journey easy, is the way for us to look to the future. It's a vision that has driven our R&D organization day in and day out. The result of this vision is what we're talking about today. Imagine a world where complexity is replaced by clarity and where different systems converge to a single intuitive platform, where your automation solutions are future-proof. We believe we've fulfilled that, and that time is here. What we're showing is the culmination of years of dedication through R&D and a profound understanding of robotics and automation needs. I've been at Kuka for 20 years now, and I've seen a lot of changes in the company and the industry. Most of you have seen a timeline similar to this in some of our presentations. Kuka started way back at the turn of the 20th century in the late 1800s, creating acetylene gas to make urban lighting economical. That grew into a welding business, and by the 1950s, Kuka was a leader in spot welding automation. In 1973, we developed the first 6-axis electromechanical robot. Kuka has continued to innovate with leading products like the first PC-based controller, OmniMoves, and the EVA collaborative robot. Starting in 2017, our technology transformation started to accelerate. With the acquisition of Visual Components, this marked the start of a digital transformation. In 2019, the first generation KRC5 controller was introduced. Now, what you may not know is that behind the scenes, our R&D was also transforming our software core to a new generation of technology ready for the digital age. You could say we've been digitizing our decades of experience. In parallel to this innovation in our robotics core, we formed a new business entity called Kuka Digital. Kuka Digital is completely software focused. It consists of visual components, device insight, and mosaics. These companies complement the technology leadership of Kuka Robotics, Swisslog, and Kuka Systems. The synergy between the Kuka companies enables us to create a digital sphere that meets the evolving customer needs in today's world of disruptive technology. We have all this experience and capability. This is how we're focusing it. That term Kuka Digital Sphere refers to the entirety of our software portfolio surrounding our core mechatronics platform and helping you as a customer to come from your first idea to a running production line as efficient and smoothly as possible. So we're introducing the new products. It's a trio of 3 pieces. There's iiQKA OS2, iiQWorks, and the KRC52 robot controllers. They're designed to simplify that complexity and accelerate deployment and future-proof your production operations. Now, before we get into the details of those, let's talk about the user journey. Because at the end of the day, automation is really just a journey from a concept to a production reality. And that's why we've designed the iiQKA OS2 and iiQWorks system around that customer journey. We started with a blank slate and talked with real users to understand their needs in key phases from idea all the way through optimization. It all starts with an idea, like a napkin sketch, a conversation in a meeting where people are brainstorming and saying, what if we could automate this process? What would it look like? What kind of robot would we use? With my Kuka as part of the overall plan, you can start your automation journey and explore robots, software, and options. It makes the complete Kuka marketplace available and gives you this opportunity to see what options you have. Once you know some of your options, you can start to really sketch out the system with Kuka's new engineering suite called iiQWorks. With simulation, you can quickly mock up a layout and build a concept by putting together components from our e-catalog. You can verify feasibility by testing reach, motion, cycle time, and this piece is free to use, so there's no barrier to entry. It's where the integrator becomes the architect and starts to bring their idea to life. Exploring different concepts without committing to the hardware, it enables you to answer questions like, can we do this? What robot would it take? What scale is the cost? And that all happens in the quoting phase before a project even begins. So that's how Kuka's innovation is supporting your innovation, where you can turn ideas into proposals in just minutes. Once the concept is developed and you won the order, it's time to work through all the design details. This is where the digital twin shines. You can import CAD files and use the virtual robot controller to simulate the entire process before you ever get to your robot hardware. You can even connect a PLC to test logic and simulate material flow with NVIDIA physics. It's a digital twin of your real system. And because it's all virtual, you can iterate quickly and try different options. You can test different configurations, optimize paths, and avoid those costly surprises at the end of the project. So by de-risking it, it improves your return on investment. Since the toolkit is completely integrated, when it's time to deploy and go live on the customer floor, you can use iiQWorks to deploy the project to the real controller. And the digital twin enables you to pull much of the effort forward in the design process so that your actual integration time is reduced. Once production starts, you can use iiQWorks to monitor status, perform backups, and manage software versions. With our focus on easy operation, we have a UI that's intuitive, responsive, and helpful. So basically, when the life cycle of the cell is complete and you want to look at how you might be able to repurpose all the assets there, reuse your robots and the equipment, it gives you the tools to continue that circular economy and reuse things and repurpose them. All right, so coming from the user journey, the new Kuka system consists of three main components. We have our iiQKA OS2, which is a flexible, customizable, and scalable operating system that controls all the Kuka robots. iiQWorks is Kuka's all-in-one engineering suite designed to make automation easier, faster, and more intuitive. And then we have our new controller, the KRC5-2. It's our next generation controller platform, which is smarter, smaller, and more powerful. These aren't just products, they're a unified, intelligent ecosystem designed to handle all those mega trends head on. We have iiQWorks, our all-in-one engineering suite. So whether you're planning, simulating, or deploying a robotic system, it brings everything together in one seamless environment. It combines decades of Kuka's automation experience into a user-friendly platform that empowers both experts and newcomers to get robots up and running with minimal effort. It's a tool where users can visualize, configure, and program robots in a virtual space before ever touching the shop floor. iiQKA OS2 is our flexible new control system that controls the whole line of Kuka robots. It isn't just an update, it's a revolutionary leap forward where we rebuilt the entire control system from the ground up based on our original Kuka system software, but applying new software technologies like state-of-the-art tech stacks and the latest web technologies. It unlocks also entirely new options, like a new user experience and workflows to simplify operation. And finally, the KRC5-2 controller is designed to support our entire robot portfolio. It brings enhanced performance, energy efficiency, and future-ready features like AI integration. The compact footprint and improved thermal management makes it flexible and perfect for tight spaces. It also simplifies serviceability with minimal components and increases uptime. So the focus on the user needs and experience is realized almost completely in the software realm. And it makes it very flexible. We use our engineering suite, iiQWorks, like a master control center. So with it, we can transparently select and interact with real robot controllers and virtual simulated controllers. That new architecture also enables the possibility to run those VRC virtual robot controllers natively right on your engineering PC to achieve the best possible accuracy and develop much of the system before you have real hardware. It has the exact same core software that runs on the real robot controller, so it's a true digital twin. And let's take a moment to talk about digital twins. We've taken the best parts of our previous simulation systems, like the Kuka system software and Office Lite and Office PC and Kuka Sim. And we put all that power into a single environment. It's kind of a digital doppelganger of the real robot system, enabling extensive planning and optimization and reducing the risk before you actually do any physical integration. It stems from the interplay between iiQWorks and the iiQKA OS2. Remember the challenges we talked about with the cat food plant? Well, this digital virtual twin gives you the ability to pull ahead a lot of that development and test and validate a system early in the design process so you don't get squeezed by hardware delivery or build times. And you can test much more of the system ahead of time. So let's take a dive in and give you a feel for what it's like to use the new iiQWorks system. Here's a quick overview of iiQWorks. That's our one single engineering suite. So this is your complete way to interact with robots. It runs on your laptop and connects to the robots over the network. iiQWorks Cockpit is your control center. iiQWorks Sim Basic is free software and ideal for early stage planning and winning the sales cycle. Then you could move to this iiQWorks Sim Advanced, where the magic happens, where you can use those full digital twins and the virtual robot controller in order to really completely design your system. Part of the plan is also iiQWorks App Builder, where you can build custom technology packages and create customizations for the robot that are reusable and resaleable. So let's take a closer look at the iiQWorks Cockpit. As I said, it's the control center for Kuka robots. This one console helps you discover controllers on the network, install and manage software versions, do trace logs, and perform backups. It's also an easy entry point for all the tools in the Kuka universe. Tools like the controller manager. With that, you can see the run status of a robot, start up or shut down the controller, and create software configurations for quick switchover. You can also manage your local virtual robot controllers in exactly the same way, so it's seamless. Our powerful oscilloscope trace tool is still built into the system, but accessing it through the cockpit console gives you network accessibility for the power of remote management and diagnosis. It also allows tighter integration with Internet of Things technologies like IQOT. You can launch SIM right from the cockpit as well. This is your gateway to my.KUKA for license management and Expert for documentation. With the license management, every newly released software package or OS version will be visible right over the network and available for easy download and testing in Sim Basic. And of course, we don't want to limit you, so you can also add your own software integrations to make your workflow even more efficient. iiQWorks Sim Basic has all the functionality that we had before in WorkVisual, but now it's built in a 3D environment. So that simplifies things for configuration of the robot, because you can check reachability, teach motions, and even test cycle times with the RCS module. You can do everything from this single tool, including I/O mapping and configuring safety zones. And because it's all in the 3D environment, many of these operations are very intuitive with more of a drag and drop interface as compared to the old WorkVisual, where there was a lot of inputting of numbers and visualizing in your head what needed to be done. When it's all done, you can still push the settings and the configuration to the real robot. Sim Advanced is a subscription-based software, similar to what we have currently in Kuka Sim. You can fully integrate with your design team by importing CAD models from a large selection of different formats. There's also process add-ons for things like welding to accelerate your productivity, creating collision-free paths, and doing CAD to path with click-on geometry. Offline programming is easy. You have the powerful KRL editor built right into the system, and you can test all the programs live right in the system. It also includes things like NVIDIA physics to simulate material flow and interaction of objects so that gravity can act on them and they can move and bounce off of each other. And the full virtual commissioning capability is also very powerful. It's not just the VRC robot controller. There's also integrations that enable you to link to real PLCs through OPC UA or Siemens Simit or WinMod. You can even simulate safety signals with this system. As we were designing the new user interface and looking at that user experience and the needs, we also decided it was important to create a consistent view. So what you see here are a couple different views. On the left is the view in Sim, and on the right is our new web UI that you see on the pendant. So the appearance of everything is pretty consistent across the usage of the system, which helps with operator training and familiarity. So we've seen a lot of pictures so far. Let's take a quick look at the tools in action. Here's an example of configuring a new robot from scratch. For the sake of time, this is accelerated, but you'll notice a timer in the upper right. We begin by dragging the robot in and then do the same with the conveyor. The conveyor can be sized with parametric settings. Adding a gripper is easy as well. We drag it in and use the plug and play feature to automatically connect it to the robot and assign interface. Then we proceed to map the I/O for the internal I/O board. We can group select all the sets of signals to connect them quickly. When we connect the hardware signals, it automatically assigns simulation actions to activate behaviors in the sim world as well. When we're done, we can click on the top level node and review all the connections with a single click. So you can see that appear in the bottom center window. We want to assign names to all our I/O, and those can be done individually, but in this case we have many, so we'll use the text import feature to assign all the names from a CSV file. We can configure the safety for the operator interface to be either the SmartPad Pro or the Smart Plug. Other safety features will also be easily integrated. As we prepare to deploy this over the network to the robot, we pull in the cockpit and use the controller manager to create a new software instance, basically like a project. And we install the new latest iiQKA OS version. That's fairly easy to configure. And then we can deploy to the robot. The new instance is visible right from the pop-ups. And as we deploy this over the network to the robot, we'll use the IP address to the controller. Finally, as we start the deploy and it begins to restart the system, we'll pull the cockpit back in to monitor the startup status of our new project. And it eventually turns green. and that the new robot controllers started. So looking at the timer, it's not really bad. A complete robot configuration and startup in about 11 minutes. iiQWorks gives you a lot of tools to improve the design cycle. Here we see on the upper right the different modes you can use. I've talked about simulation, and you can simulate and estimate cycle times in the with the RCS module in Sim Basic, or in Sim Advanced, you can use the VRC, which provides a higher level of fidelity for options and tech packages since it's full controller software running. There are other useful features as well. The modes like remote view can mirror the runtime of the robot so you can watch the performance. The controller view is also really useful for debugging since it enables you to look at programs and variables while the program runs on the robot. In our old system, you could use the free software, WorkVisual, to configure and program the robots. But if you wanted to do any 3D work or cycle time analysis, you needed to purchase Kuka Sim. So we changed the game with iiQWorks. Now all the functionality of WorkVisual is built into Sim Basic. Plus, you can concept your cell in 3D as well. You can do reach studies and cycle time analysis. Sim Advanced now is the purchase item, and you can get that powerful set of features we mentioned earlier, including the digital twin and full programming of all option packages. And there's various modular add-ons like modeling, connectivity, and path generation. One of the new and exciting add-ons we're also working on is the AI Copilot. This can help you do simulations and write programs through natural language prompts, kind of like a ChatGPT concept. In partnership with Microsoft, we're building an AI infrastructure, as well as developing and validating AIs to generate and edit programs through natural language prompts. So this can really lower the barrier for people who are not familiar with Kuka languages, and it can accelerate your development. In this example, the user simply types a prompt, get cubes, and place them in an X shape. And that prompt generates all the KRL code to be created automatically. Note that this is a sneak peek, and it won't be available till late this year or early next year in North America. Let's move on to iiQKA OS2. It's our single, flexible, and customizable OS. It's Linux-based system, giving you stability and security. The software ensures that the robot will be ISO 10218 compliant, as well as prepared for ANSI RIA 1506, coming in 2026 and 27. It's a cyber resilient system that will be protected and cyber secure, and it'll meet all the upcoming standards. We've already talked about ease of use. The new web-based UI is something that we'll look at a little bit more carefully soon, and that's really key. And the integration with iiQWorks is another really important feature. It's one system driving the whole Kuka portfolio. With the whole state-of-the-art engineering and a modern tech stack, it makes it quite future-proof and more capable, enabling Kuka and our customers to move faster into the market. So we've been talking about it at a high level, and let's take a look at a couple details here. One new enhancement is to the KRL language, and there's new motion features supported. We have some new motion types like as fast as possible, process, or smooth process. These are quickly and easily assigned by the user to particular motions to change the behavior of the robot. So if you have an application that requires fast cycle time, you can do sim motions with the AFAP type and then switch over to the smooth process to do very fine operations, say like a dispense path. So the OS capabilities are great, but accessing them is the real key. And that user experience is something we've focused a lot on. Part of that is that we have some different ways that you can interact with the robot. It's a web-based interface. So now you can use your laptop with a simple browser to actually see what the robot controller view is and to interact with the robot system with a virtual pendant. There's also what we call the smart plug, which is a low-cost pendant solution where you basically just have the orange handle as part of the Kuka supply, and then you can bring your own favorite tablet, Android, Apple, or Windows, and use that as the operator display. And finally, we still have a SmartPad Pro, which is our traditional industrialized and hardened rugged pendant. It provides good protection and ergonomics for use with either right or left hand, as well as the Space Mouse. Here's a quick comparison of the features and capabilities of the different pendant options. The SmartPad Pro is hot pluggable and has the 6D mouse, as I mentioned. The new user interface is also very rich and visual. The larger screen format definitely helps, but there's a lot more options as well in terms of how the user interface is displayed. There's things like step-by-step guidance through pictures and help text, so it minimizes the need for training. And things like tooltip pop-ups help guide the user and highlight what to do. So let's take a look at an example of those tooltip pop-ups. In this example, we just configured a new robot, and we can see there are some errors. As we look in and see this one error, it notes that the safety configuration wasn't confirmed. So we want to take care of that. As we go to the safety menu, the approve button is disabled or it's grayed out. Then we hold our mouse on it and see the tooltip pop up. And it shows that this requires single point of control and the user level required is safety maintenance technician. So we know what we need to do now. And so we go to the user management page and select single point of control and change our user level. And then when we come back to the safety page, voila, the approve button is enabled and we accomplish our goal. Now on some systems, an inexperienced operator might spend 30 minutes searching manuals or calling for help because they just didn't know those details. So this guidance on the little details helps everyone to be more efficient. Here's another example of efficiency and usability, a direct comparison between the old software and the new system. With the old software, it took 6 menu clicks just to get to the mastering page. And even then, it just listed a set of axes, and it wasn't really obvious about what to do if you didn't have training. With the new system, it's readily available with 2 clicks to get to the menu. And then you get a wizard-based guidance with pictures that show you exactly what you need to do on the real robot mechanism. This is another example of how the new visually rich HMI simplifies the user experience. In this view, we see the TCP tool teach wizard. It provides a step-by-step guidance for the process, and the pictures give visual clues about what the user needs to do. This can be really valuable for someone with minimal robot experience or someone who hasn't used a Kuka robot. iiQKA.OS is also designed with the idea of extendability built right in from the ground up. The architecture is open and extendable to grow and meet changing needs. We brought this mentality into the new iiQKA OS2. We have an app builder to enable you to create your own install packages. So you can make your own native COP files, just like our packages install. So if you have standards or custom IP that you've developed to run on the robot, you can package those up in a native distributable package. And that can tie into our Kuka ecosystem. These fully integrate into iiQWorks. And it includes features that enable you to build your own HMI, formerly known as HMI Easy, and things like user text, so you can create your own command lines. These modular software components extend the robot capabilities, and they integrate seamlessly like a native application. We also have some more detailed levels, like the application developer kit and the SDK. These open APIs enable more customizations to be built on the native robot system. We also have the plans for the Kuka portal that enables an ecosystem. So if you've developed something special, you can monetize it by selling it to others on the portal. Or if you're more of a user and you just want to be able to access the best technology available, you can also purchase items built by other creators. Either way, it gives you ways to accelerate your deployment. Let's talk a little bit about the hardware. The KRC52, it's not just a controller, it's a new brain for the next era of intelligent systems. Our vision begins with high connectivity. The system is inherently AI capable and ready for advanced applications. Extensive interfaces through hardware and programming APIs enable it to be extended. So that gives you seamless integration across the factory floor and flexibility for different applications and to grow in the future. The total cost of ownership is also dramatically reduced through high reliability and simplified number of components. So it's engineered to be truly future-proof, and it's already prepared for some upcoming regulations and standards like the ISO 10218 and the IEC 62443. ISO 10218 is really changing the industry because it requires new safety levels that essentially are causing all robot suppliers to have to redesign their safety. So this system is ready for that and fully prepared. Another huge thing is this IEC 62443, which has to do with cybersecurity. While that's a European standard, it really affects everybody globally. There's been a lot of stories in the news where hackers gained access to industrial systems or public systems that caused havoc. So this new hardware architecture is hardened against those sorts of attacks. The new system is also scalable. The microcontroller is stackable, and the full-size controller enables multiple control units to fit in a single control cabinet. There's also extendibility, where you can add physical I/O, field bus hardware, or additional axes into an expansion area. But one of the most exciting pieces of the expansion capability is what we call our AI board. This is actually an NVIDIA Jetson processor, which is a high-performance GPU-type processor that can be embedded right into the controller. It's fully integrated and designed with a high-speed interconnect. NVIDIA technology gives a lot of high-end processing capability, leading towards that AI embodiment. We have a reference implementation of 3D vision on the AI chip, but NVIDIA also has other high-end algorithms like scene segmentation, which breaks down the visual space into real objects, so the system can differentiate between things. Human pose recognition and teach by gesture are enabled in real time, so that you can have new modes of interacting with the robot. And things like audio data can be processed in real time as well for voice recognition. As mentioned earlier, that robotics ChatGPT moment is just around the corner. It didn't necessarily talk about specifically industrial robots, but it's important to emphasize how our forward-looking architecture with the AI board will help to reach this vision and be prepared for that future. When we think about a manufacturing and production environment, we have to have a robust, always available, and resilient processing capability to do and implement these future type capabilities. Our partnership with NVIDIA enables this. So in summary, we've looked at this user experience and designed our new system capabilities to be easy to use and take into consideration all the needs of our industrial users. It gives the best possible product for user experience regardless of where you are in the journey. iiQWorks gives all the engineering suite capabilities in one seamless environment. It enables you to work efficiently with the system. The new OS and controller are integrated completely. And if we think about the effort curve in an integration process, there's usually a lot of effort up front in the design. So with our new system, iiQWorks can reduce that amount of effort. It also reduces the amount of effort during startup and operation by simplifying the user experience. Overall, that drives a reduction in the amount of time it takes to integrate new systems. And when you multiply that by many systems, you can implement more automation faster and more easily, saving time and cost. Thank you. I appreciate your attention today.
Thank you. That concludes the presentation portion. Thanks, Pat, for sharing your presentation with us. We did have a few questions come in, so we'll go ahead and start rolling into those. First question is the LBR EWA system supported in this new architecture?
No, the LBR IIQWA is an older generation of technology, and so it will not be supported. But our newer collaborative arms called the Easy, the LBR Easy, those will be fully supported by this.
Awesome, thank you. With iiQWorks Sim Basic, can we program a physical robot or do we need Sim Advanced?
You can program a physical robot with SimBasic. So you can do a single robot in the sim environment, set up all your programming and configuration, basically everything you used to do in Work Visual, and deploy that all to the robot.
Perfect. Another one here, KOP editor will also be embedded into iiQWorks. This is a question, or should we still buy it separate?
The what used to be the KOP editor has been evolved into a new software package, and this was the app builder that I had mentioned. So app builder is a new generation of tool that gives you the ability to build your own option packages, but it also includes capabilities of what you previously knew as HMI Easy, so you can build custom screens for the system, and what was previously known as user tech, so you can build custom inline forms or commands that can run in your program. All of that is integrated completely into the app builder.
All right. It looks like we might have time for just one more here. Can you make a code change remotely with Cockpit?
No, code changes are not something that you do with Cockpit. That would be done through the iiQWorks sim.
All right. All right, guys. Well, that is all the time we have for today. Thank you for joining, and thank you, Pat Duda, for being on this webinar session. We will see you guys next time. Thank you, everyone.
Making automation easier.